My name is Kanika Garg, and I have been working in artificial intelligence, machine learning, and data science for past 8 years. Today, we are going to discuss on decision trees. Moving further, these are the topics that we are going to discuss today. What is decision tree induction, or say decision tree algorithm? We will talk about these two algorithms in today's lecture. Then how to select features to create any tree, or say the decision tree. Then we will see a working example, and then finally we'll go to the recommended courses. Now let's see what decision tree is. Decision tree induction is basically a method of learning the decision trees from the training set. The training set consists of the attributes and the class labels, or maybe the regression values. So the application of decision tree induction include the astronomy, financial analysis, classification, any maybe medical diagnosis, manufacturing, production, everywhere we find its applications. Okay, so it is basically a flowchart like tree like structure that is made from training set tuples. Okay, so the data set is broken down into smaller subsets and is presented in the form of nodes of a tree. The tree structure has a root node, like if you can just see here, there is a root node, age, and then it has some children, student, and then credit rating, and these are the values associated with it. So if we say if we had a certain age and it's young, so we say if the age is of the younger person, then whether it's a student or not. Okay, if some middle aged, then something, and then it's senior, then whether that person has a credit rating or not, right? So this kind of a tree is created, and the very first node, of course, is called as the root node, the last one called as the child nodes, and these are the internal nodes. Now the internal nodes and the root nodes are called as the decision nodes, because here we are actually making the decision whether it is a student or not, whether they had a credit rating or not, or a bad credit rating or not, right? And the leaf nodes and the branches, these are the basically decisions that we made, right? So what are the features basically we are learning here? The feature we learn here is the feature that provides us the highest information. Okay, or we say the lowest impurity. How we understand anything, whether it provides us the maximum information or the least lie. Okay, so basically we are just doing the refinement here so that we can just get the better quality information. So the root node is the topmost node. It represents the best attribute selected for the classification. Okay, so the internal nodes of the decision node represents a test on the attribute of the dataset leaf node, or the terminal nodes, which represents the classification or decision label. So the branches shows the outcome of the test performed. Now, if you see here, the test has been performed on the variable or the attribute age. So they represents the test performed, whether these are young, middle-aged, or senior, right? So some decision trees only have binary nodes. That means exactly it has two branches, but as you can see, it has three nodes. So it is not a binary tree, it's a ternary. Now, moving on to the very first algorithm, very famous also, called as the C4.5. It's an extension of ID3. So ID3 and C4.5 follow a greedy top-down approach for constructing decision trees. If you have learned about the greedy approach in your BTech studies, that you'd be familiar of the word. The algorithm starts with a training data set with class labels that are portioned into smaller subsets as tree is being constructed. This is the basic thing that we are doing in any of the algorithm, right? The way it differs is that where we split, okay, that measure is called as the gain ratio here. This is the term where this algorithm differs. We say either the gain ratio or the information gain. So the node, or say the attribute, has the highest information gain will create the root node. And then moving down further, we will decide upon the nodes based on the information gain or the gain ratio value. So we will be using this attribute to select the best attributes for splitting the data. Okay. Now, why it is famous? Because it can handle large data sets without uh, getting into the infinite loop for creating the tree. Now, C4.4 can be used for both classification and regression. Moving on to the next very famous algorithm called as CART. This is basically classification and regression trees. These are the algorithms that build decision trees using the concept of the Gini index that we will study further. This is the main difference between the previous algorithm and this algorithm. The previous algorithm works on the information gain. The highest information gain attribute will make the root. Here we'll work on the Gini index. That means it is the basically measure for the impurity. So that has the least impurity will make the root node, right? So CART only considers binary splits, meaning that it can only handle categorical attributes, because generally the categorical attributes has the values of yes or no, 0 and 1. So generally it has the binary splits. CART is easy to understand and interpret, and the tree structure is of course easy to visualize because it's creating only the binary splits. It is well suited for complex non-linear relationships within the data and can be used for both regression and classification. Okay. Now, C4.5 and CART, these both are the decision tree algorithms that can be used for both classification tasks, but they do have some differences. Like C4.5 is an extension of ID3 algorithm and is able to handle both continuous and the categorical attributes. All right. So for C4.5, we say it use both the categorical variables and the continuous variables. Whereas for CART, it only can consider the categorical attributes. Okay. Now, another point of difference is that C4.5 works on information gain, and whereas the CART works on the impurity percentage, or say the impurity ratio, right? So it uses Gini index to measure the impurity of the split, and it's more efficient generally on the large data sets, because sometimes it's difficult to understand how much information they are providing, but how corrupted or say how impure they are, sometimes it's easy to visualize or to interpret. Okay. And both the algorithms, they are being widely used in data mining and machine learning, and the choice between them largely depends on the characteristics of the data. Like if you have more of the categorical data, we'll prefer CART, but if we have more of the continuous data, we'll prefer C4.5. Okay, whereas CART would be more suitable with the categorical variables. Now for feature selection, we talked about two concepts for feature selection. One is the information gain and another one is the Gini index. So here let's talk about the information gain first. Information gain is basically based on the concept of entropy. Now this is a very famous example. So entropy is basically the measure of the information, or we say it is an important term in information theory, which is a branch of mathematics that studies the quantification of information. Okay. So information gain is basically a way of measuring how much a feature helps reduce the uncertainty about the target variable. It's an interesting way of measuring the correlation between the feature and the target variable. Target variable, I mean to say the output, right? Whereas, let's see about the Gini index. Now, Gini index is a measure of, say, impurity, which is used in decision tree algorithms to determine the most informative feature for splitting the data. The key features it has is it measures the probability of a particular feature being classified incorrectly when chosen randomly. Okay, so it's basically a degree of probability of a particular variable that it will be wrongly classified. Okay, so sometimes say when we see a data and we misunderstood that data and we misinterpret the information that it conveys. So it measures that degree, that probability that it will be misconveyed. So Gini index is calculated by subtracting the sum of the squared probabilities of each class from 1. So the values ranges from 0 and 1, where a value of 0 represents pure data. That means it has no errors. That means all data belongs to a single class only. And a value of 1 represents the impure data, completely impure data. That is, data is evenly divided among all the classes. So we cannot just favor one class. So Gini index is a measure of homogeneity of the data, where a lower Gini index indicates the data is more homogeneous. Okay. Now let's see an example. Now this is a very famous example for decision trees. You can easily get it from the internet or anywhere because this is easy to understand. So let's see, we'll be working on the card here right now. If you see, we have some attributes and finally it will calculate or it predict whether the football would be played or not in the terms of yes or no. So it sees the outlook, whether it's sunny, overcast, rain, the temperature, hot or cold and mild, humidity and wind. If all favors, then we play, otherwise we do not. So we have to predict. Now there is one way, this is one way of creating the decision tree, right? So first, if I consider weather, then my graph could go like this. So if it is sunny, if it is cloudy, it is rainy. Then if it is sunny, then we'll talk about the humidity, and here we will talk about the wind, right? Other graph could be like topmost, I can have a humidity, then I can have weather, and then we can have wind, right? So these are the kind of graphs we can have here. For our example, let's see. Now, let's go back and see the table. Let me just take the outlook attribute first and let's calculate the values based on it. Okay. Now here, let's first understand or find out the entropy of the class variable. How many no's and yeses are here? If you just see here, 1, 2, 3, 4, 5 no's and 9 yes are here. So here I can just find out the entropy, like 9 by these are the 14 entries, right? Then log 9 by 14 plus 5 by 14. I'm sorry. Log by 14, right? So let's just calculate this value and it will come out to be somewhere near 0.94. So this is basically the entropy of this whole set. Okay. Now we'll talk about each variable one by one. What you can do is you can just go and calculate similarly the values of entropy for sunny, overcast, and rain for the outlook variable. Okay. So I have created a table for the similar calculation here. Now we can just calculate the entropy value with respect to this variable outlook. Okay. So if you see, we have three variables or say values for the outlook here: sunny, overcast, and rainy. So let's calculate 5 by 14. The total values are 14 into E of 3 comma 2 for these two, right? Plus 4 by 14 into E 4 0, like for this. Then plus 5 by 14 into E 2 3. You will calculate E the way we have calculated previously. Like this would be, let me just do it for one variable for you. It will be minus 3 by 5 log 3 by 5 plus 2 by 5 log 2 by 5, right? Then similarly, this is for this term. Then for this term, we will have 4 by 14 into 0, because this will give you 0 information, right? And then finally for 5 by 14, 2 by 5 log 2 by 5 minus 3 by 5 log 3 by 5. So this whole will give you some value near, right? Similarly, you can find out the information gain between the final variable and the outlook. That was 0.94 minus 0.693. That is somewhere near 0.247. Okay, so this is the perfect value here. Now, similarly, you can find the same value for the next variable, like temperature. So this is still coming for the outlook. The same thing you can calculate for the temperature, and then you can just see that this will give you some values. Okay. And then finally, you will choose the root node which has the maximum information gain. So in our case, when you'll go further, it will give you the values of outlook will be the highest. So outlook will become your root node, and then it will give these three value nodes and rain. Now overcast, for overcast, if you can see, it will always be yes. So whenever the outlook is overcast, the game will be played. And then for sunny, we will further calculate for say temperature and maybe humidity, wind. That will all depend on then their information gain. Okay, so this is how we calculate the entropies and then finally the information gain. So our final tree would look like something this. This is humidity. This is wind. And this is, yes, for the overcast. This is sunny, this is overcast, this is rain. Then again, for humidity, it will be high, it will be normal. And then no, yes, then strong and weak, then no and yes, right? So this is how we create a decision tree. And this is how we code. So the coding will be followed in another video. Finally, thank you. And thank you for watching the video. Please like, share, and subscribe if you really like the video.